We have seen transformations before. Now I want to focus on deformations, which are basically transformations but applied to each fragment. First of all, I'm going to create two folders and load some textures. Next, I'm going to create a mesh instance, a plane, a shader material, and a new shader. I will call it waves, sine waves. Now I'm going to create a group of uniforms, then a uniform variable deformation strength, then deformation frequency, now a UV variable, and then just assign function to draw some lines. Now I'm going to create a second function that will be used to deform the first one. I assign it to albedo so you can see the result, and I can apply deformation, strength, and frequency. So I'm going to create a new mesh instance, a plane, a new shader material, and a new shader. I'm going to call it sine cosine. Then I define a few uniform variables: albedo, distortion, and time scale. I define a vector variable to hold the size, and a new vector variable to hold the deformation. So I apply cosine and sine for the x and y axis. And then I apply this transformation to the texture. So I get just circular movement, but what I want is to distort each fragment. So I add the x-axis, and you can see the difference, and then the y-axis inside the functions. I can multiply by a different factor, so you can see this nice effect. So I apply the time scale, and you can see that the result is much better, and they really look like waves in the water. So I duplicate the plane, make unique recursive, and just delete the code inside the shader. I'm going to declare two uniform variables, the center and the force. And that is because this effect is a distortion from the center to the UV position, but normalizing this value so that the displacement at first does not exceed the value of 1. I apply the distortion to the texture, and you can see the result. Now I'm going to apply a mask to the effect. I am using the circle function, and I'm going to define a new function. Maybe this function should be called torus, but I like it that way. So I define the inner circle and the outer circle, and then I just apply a subtraction to get the final shape. I just save the shader, and I am just going to apply the mask with animation. I define a new uniform variable for the thickness of the mask. I make an interpolation between the distortion and the mask, the distortion and the UV, so you can see the effect, and it looks very nice. I duplicate the plane again and make unique recursive. Save as warp GD shader, and I'm going to delete all the code and define two uniform variables for the textures, albedo and noise, and another 3 float variables for the strength, the speed, and the scale. I'm just copying this function that is a blending mode between two textures. I define one variable for the warp in x-axis and another one for the warp in the y-axis. So I apply the functions to the distortion offset and then apply this to the texture. I apply the overlay effect, but I need this texture and apply the noise. You can see the warp effect. It has to be very low. Apply noise as an overlay and it looks much better. And this is the result. The next one is a texture-based displacement. It means that we are using the colors of a texture to displace a second texture. It's like a normal map, but in 2D space. So we are using just the R and G values. Here is the distortion map as a uniform and the distortion value or strength. I load the distortion, I apply animation. In the negative positive space, I apply the distortion to the UV. You see I am using the R and G channels. I apply it to albedo. I put some values into the distortion. I load the texture, you can see R and G, and you can see the result. So it's very interesting. The last effect is perhaps for not leaving out the GODOT icon. It's about deforming the UV space into a circular shape. So I use that function spherify. I load the texture and you can see the result. I'm just going to adjust the GODOT icon so it looks good. And this is the end.